Hey everyone, welcome back to Cloud AI Nexus 360. Today, I'll be breaking down the full workflow behind the AI avatar generator I built. From the moment you click generate on the front end all the way through to AWS Backend. Bedrock, step functions, ffmpeg, DynamoDB, the works. I'm back to the browser with a downloadable video. If you've seen tools like HeyGen, this is my serverless AWS native version. It is fully serverless, production grade pipeline, and today I'll show you exactly how these pipelines are stitched together. I'll also do a comparison between HeyGen and Novorail. Thank you. At a high level, the workflow looks simple on the surface. You type your script, upload an avatar, and click generate video. But beneath the hood, a full AI pipeline springs into action. We have a front end, an API layer, which is powered by the Amazon API gateway. Orchestration happens via step functions. AI services like Amazon Poly and Bedrock Novorail. Storage in S3, job tracking in DynamoDB, and finally a Docker-powered ffmpeg Lambda that merges audio and video into a single MP4. On the front end, everything starts with a simple form. The user uploads their avatar image. The user then types their script, then selects essentially their gesture style. They will need to basically choose their voice and then finally click generate video. Under the hood, we first call an API endpoint to create a job. Then we pull another endpoint to check status until the backend tells us the video is ready and it's going to return a download URL. API Gateway is my secure front door. It exposes 3 REST endpoints. Upload URL, jobs, and jobs job ID. Behind each of those is a Lambda function. That does just one focused task. This separation keeps the API clean and makes it easy to extend later. For example, to plug in another avatar model or even call the HeyGen API instead of Novorail. CreateJob is the producer of the workflow. It generates a job ID, writes a record onto DynamoDB, and generates audio using Amazon Poly. It kicks off a Novorail async job in Bedrock, and finally starts a step functions execution. This is where we go from just a text prompt to a fully tracked, long-running AI job. Step functions is the orchestration brain. It coordinates all the long-running paths, waiting for NovaRail to finish, checking status, looping when it is not ready, and calling the mux Lambda when it is. Instead of the front end waiting on a long HTTP call, we hand off control to step functions and just pull DynamoDB via the get job Lambda. The check Nova status Lambda polls Bedrock for the async job status. When the status is completed, it passes the S3 bucket output URI, finds the MP4 file, and saves that key into DynamoDB table as Nova video key. If it is still in progress, we just return pending and let the step functions loop. Here is one of the biggest gaps with Amazon NovaRail compared to tools like HeyGen. NovaRail returns video only, no embedded audio. There is a no true limb syncing engine built in. So I generate the audio with Poly separately, then use Docker-based ffmpeg Lambda to merge the two into a final MP4 video. This is where the glue, talking head from NovaRail, and the speech from Poly into one file the browser can play. DynamoDB is a single source of the truth for each job ID. And S3 stores all the media uploads, the audio, the raw NovaRail video, and the final merged output. The front end never talks directly to Bedrock, Amazon Poly, or ffmpeg. It only ever sees a simple job record and, when ready, a pre-signed URL for the final video. The get job Lambda is what the front end pulls. It reads the job record from the DynamoDB table, and when the job is complete, it generates a pre-signed URL for the final MP4 so the browser can download it securely. So from the browser's perspective, it is just pending, completed. Here is your video link.
Welcome back to Cloudaining Zoo 360, where cloud projects meet intelligence innovation. Welcome back to Cloudaining Zoo 360, where cloud projects meet intelligence innovation.
So putting it all together, the front end stays thin. It just calls jobs, gets a job ID, and pulls jobs/job ID. Behind the simple UI is a fully serverless AI pipeline using API Gateway, Lambda, step functions, DynamoDB, S3, Amazon Poly, and Bedrock Nova Rail, plus a Docker-based ffmpeg Lambda to merge everything into a final MP4. Now, how does this compare to something like HeyGen? Today, Nova Rail has a few gaps. It doesn't embed audio. We fixed that with ffmpeg. It doesn't do true lip sync like HeyGen. Mild movement won't perfectly match every phenom in your script. Facial expressions and realisms are good, but not as polished as dedicated avatar platforms. The cool part is this architecture is modular. I can swap Nova Rail for HeyGen's API or another avatar model. I can insert a self-hosted lip sync model like Wave2Lip or SAT Talker in place of ffmpeg, or replace ffmpeg Lambda with Media Convert for more advanced encoding. If you like a full repo or a build along session for this stack, let me know in your comments. And if this gives you ideas for your own AI video workflows, hit the like button, subscribe, and share this with someone building on AWS. Thank you.